let's look at some properties of definite integrals. And these are going to feel pretty similar. Hopefully they feel familiar. And that's because these three properties are kind of inherited from our indefinite integral properties. Indefinite integral properties. Kind of hard to say. So really, these three properties we have listed here, they are inherited from our indefinite integral. All right, so what is the first one? Well, it says if we're doing a definite integral of f of x plus g of x and we're integrating from a to b, well, we can just split up the integration. Do the definite integral of f of x from a to b, do the integral of g of x from a to b, and then just add the results. So we can split up where we have an addition sign. So instead of integrating f of x plus g of x, just integrate f and then add it to the integral of g. Very similar to what we saw with indefinite integrals. Same thing goes for subtraction. If we have a subtraction sign, well, if we're integrating f of x minus g of x from a to b, well, instead of integrating this entire function, we can focus in on just integrating f of x from a to b. We can focus in separately on integrating g of x from a to b, and then just subtract the results. So what these two really show is that we can split up the integration. At plus or minus signs. Multiplication and division are something completely different, but for addition and subtraction, we can split up the integration, just like we were doing with indefinite integrals. So sometimes we call this like the sum rule. Maybe call this the difference rule. These are things we've seen for indefinite integrals. And then we also have, right down here, a constant multiplication rule. So we have this other property where if we're calculating the definite integral from a to b of a constant k times f of x, well, this constant multiple k, we can move that out in front of the integration. So instead of having the constant k inside the function we're integrating, let's bring it out front. And we can just integrate the function f of x from a to b, and then when we get that result, multiply it by k. So we have this constant multiplication rule that really tells us that we can move a constant multiple outside of the integration. And that's what that k is. It's a constant multiple. And again, this is something that we saw with indefinite integrals. So we saw take this constant multiple k and just bring it out in front of the integral sign there. And we called this, the constant multiple rule. And the one thing to keep in mind, and it's an important point, is that k is a constant. So it can't have any variable pieces to it. If our variable is x, there can't be any x's here because that's no longer constant multiplication. That would be a function. That's a variable term we'd be multiplying by. So this constant has to be a constant. It has to be a constant multiple. All right, so these three properties, we'll see how they work. But these really are inherited from our indefinite integrals. And we don't normally show these three in our work. We don't normally show these three properties. We just kind of find the antiderivative just like we normally would, realizing that we can split up the integration if needed or bring out any constant multiples if needed. So really, these three properties just tell us continue doing what you're doing when you were doing indefinite integrals. Just keep doing that. Find antiderivatives the exact same way as what you were doing before, and then you can evaluate. So we'll see some examples just to get a little bit more practice.